on training, I just didn't want it to exit right away. So I just did while true. It's going to grab email features of anything you enter into the console. So if you're running this in a console, basically you can just copy and paste in whatever text, and then it'll actually, you do classifier.classify. So on our classifier object, you run the function classify, and that'll take any text you give it and run it through based on what it knows, and give it, it'll output spam or ham. And it's pretty interesting. So if you go to the GitHub site that I mentioned earlier, you can actually grab the source code, and all you need are emails. And in fact, you don't even need emails. You can put in whatever texts that are from the same corpus and see how it works. Okay, so just a few minor notes. So the quality of your input data will affect the accuracy, of course, and as well as the threshold of how large your sample size is. I think before we grabbed 70% of the emails. Changing that will actually significantly affect the accuracy of your classifier. So this spam bot actually has an accuracy of 98%, but that's really misleading. It's kind of a paradox called overfitting, where this classifier is so fit to do enron emails. It's so specific to classifying enron emails. Yes.
This is sort of about that. Looking at your code when you did the 70%, I think you trained it on 30% of the data and then tested it on 70%, which means that at least within the enron category, it was doing a pretty good job on a large section, given a small sample, or a sort of medium sample. But
yeah.
that wouldn't
that
apply
actually,
to just emails in general.
Yeah, that is true actually. So what happened is for this one I actually trained it using 70% of the entire thing, and then the other 30% was left to be the test set.
No, I think it's the other way around.
Was there overlap between the training and the test data set?
No.
No, it was
Okay.
There, see? You're starting at 70%.
Right. That is true.
Well, but there actually is an overlap. It's the first 70% is the training set, and the last 70% is the test set.
It's the last 30% and the first 70%. Right?
Yes, that's correct.
Okay, yes.
This is like basic Python knowledge. This is something you do once in a while. You want to split a list into like somewhere in the middle.
You're not shining.
And that's no. I'm saying look at this little pattern here. It's so sort of subtle and weird that you say site colon. And the other one you say colon or size colon. And the other one you say colon size. And that's what you do when you want to split a list into two groups. But then you have to, really pay attention to figure out which section you get.
Yeah, this really does fluctuate a lot. But I mean, in the end, you want to be able to get the best accuracy. And of course, that number is probably not the best threshold. And depending on, another thing that's unknown in this situation is the number of documents that we actually have, which makes a huge difference as well. This was actually a really large amount of documents. It's huge. I think it took about like.
It's a 7 point.
He's right.
The first one was everything past that, and the second one was everything up to that.
Oh, okay. Can I ask a question about misspellings?
Yeah.
Which is that, I know in my hand I'll get grammar wrong, or in fact just general getting the language wrong. You say natural language toolkit.
Yeah.
I'll get my grammar, I'm probably getting my grammar wrong right now, and my spelling is not perfect. Where in my ham emails, but in spam emails, like obviously there's things like C1Rs,
Yeah.
and all the other deliberate misspellings. I guess it's a general question, which is how does NLTK deal with the fact that humans get language wrong?
That actually, spelling errors, I haven't really looked into it. I think I've seen something outside of NLTK that basically generates all possible permutations of a certain given word, like the location of different letters. And it's,
Well, and actually the best indicator of ham in your list was a misspelling.
Yes.
It was ECT.
Yes.
well, there we go.
Let me
may say more about Enron than it says about.
Well, yeah, I mean, this isn't that advanced. It's just we're using basic features of NLTK to kind of produce some.
we know what they meant.
Exactly.
We'll never find out.
There's a peculiar trick in people reading that allows you to keep the first and the last letter of a word the same and scramble all the other letters, and you can speed read at the same speed.
Yeah, that's an interesting thing. I've seen that. Okay. Are we on time, by the way? Okay. So, a few notes. So the accuracy definitely can be misleading. One of the things that was left out of this is how many documents am I actually running this on, and that makes a difference, as well as how large of a sample you grab for both the test and training set. And so this one is clearly overfit. In fact, when I ran this on my own emails, I think the accuracy dipped down to something like 60% or something. So it's you want to make sure that you grab something, a good sample. You want to make sure that it works. The sample that you're grabbing is very accurate of what you're going to be running it on. Yes.
How are you getting the accuracy?
For this?
I mean, that's a metric of what a human thinks, right?
No, the accuracy is based off of how well it classifies. So we trained all the different. It's based off how similar the two data sets that you're running it on is.
The input and the output, it's all literally somebody classified. They were manually.
So, but then how did you decide for your own email? Based on
for my own email, I would
size?
essentially have to use my own emails as the test set.
So you're saying what's already in your spam folder, you're labeling as spam?
No.
You manually identify.
I would manually, right.
Right.
Yeah.
You noted where they were wrong or right.
Exactly, pretty much, yeah.
So if you had 10 emails before you spam, you lost.
Okay, so the next portion, I think this is the final one actually, is chunking text. So basically, we want to take a sentence, complete sentence, and break it up into different chunks. So for here, we have the noun phrase, which is the phrase the part of the sentence that contains the noun. And this actually could be broken down even further and further. So a noun phrase can contain several other phrases, and it can be broken down recursively. There's also a prepositional phrase. So it usually contains a noun, preposition, sometimes adjectives. And you have a gerund phrase, the phrase that contains ing words. And so we're going to take this following sentence, Jack and Jill went up the hill. And chunkers are non-recursive, so basically you won't see any overlap. It doesn't take a chunk and then try to break it down even further. So it'll just go linearly in segments and kind of segment it. So if we look at the recursive form of that, you can see that you can actually have certain phrases. So you can take a noun phrase and actually break it down even further. And so you have this recursiveness. And there's actually two types of recursive. It's called parsing. Two types of recursive parsers. One of them is the recursive descent parser. It parses starting at the top, looking at the whole sentence, breaking it down, and then finding more phrases within those phrases that just broke it down into. And I forget what the other one was called, but it goes bottom up.
Or left,
Yeah. There's several different types of parsers, but usually parsers are more computationally expensive. So if you're looking for performance, chunkers if you use chunkers, that can actually get you far enough in a lot of cases. Okay, so verb phrase chunking, just like noun phrase, but with verbs. Just really quick, it's just the final examples. So from NLTK chunk, we're going to import everything, as well as the regular expression module that comes with it, import that. Word tokenize again, and that's why knowing what tokens are and tokenizing it is fairly important. And the part of speech tagger, we're also going to import from NLTK. And we have our sentence. Jack and Jill went up the hill to fetch a pail of water. So in here, in one go, we're just going to word tokenize that, and then the result of that, we're immediately going to give it part of speech tags and store that in a variable. And over here, there's actually a function called chunk rule. Now, chunk rule, there are actually rules on which you're going to break apart this text using regular expressions. And the regular expressions, what you specify in the regular expressions are the actual part of speech tags themselves. So chunkers and parsers both they don't care what the word is at all. All they look at are the part of speech tags and where they are in relation to the other words in their part of speech tags.
These are not Python regular expressions.
Right.
These are NLTK.
These are NLTK regular expressions. And in fact, I kind of wish I put it up there now, but there's a function that actually converts regular Python regular expressions into NLTK regular expressions. If you look through the chunk module, you should be able to find it.
Is there some variability about what you want to use for your part of speech? Because it looks
Oh.
like you've got a fairly canonical, easier tagged words.
Yeah, oh no, absolutely. I mean, this is an extremely simple example, of course, but you can, they get really, really complex, and they get, yeah, you can make it as long as you want. If you go through the actual pen tree bank part of speech tag list, there's a whole host of part of speech tags you can go through. So depending on, how much you really want to parse out.
Well, I meant if you wanted to use some alternate set for some reason, like you're experimenting with variations on the pen tree bank, for words, and you substitute your own part of speech.
If you wanted to actually define your own type of, yeah, basically define your own part of speech, kind of.
Yeah.
So break it up a certain way and then give it a tag that says this is this kind of phrase or whatever you define.
Supposing you wanted to put swear words in their own category.
Yeah, absolutely. Actually, in fact, yeah, one of the I think you'll find online a lot of the examples do assign it the part of speech tag of chunk. So it just says chunk, chunk, chunk. Like it doesn't really say which part of speech tag, but for this one, yeah, you can get really creative with this. So essentially, we have the chunk rule, which is what it's gonna use to chunk the sentence into different parts. The chink rule is things that it's gonna break out on, and that it's gonna remove basically. So if it sees, it's I believe that's, yeah. So it's a verb and a preposition right next to each other. It's going to take it out, ignore it kind of. And the split rule, you basically, if you have a determiner right next to a noun, that's what it's gonna split based on. And we actually run that through the regex parser, chunker. And basically, right there is where you would label it actually. If you see at the bottom, chunk no equals, that's where you can actually call it whatever you want. So you can put chunk there, and it'll actually split them out and then put labels for, it'll call it chunk. And then you would actually parse it, and the interesting thing about this is if you have tkinter installed, you can actually draw the tree that it parses into. So not only when you do chunker.parse, it'll actually output a bunch of, a list of objects of where it kind of broke things out at. But if you want to see it visually, you can actually do chunks.draw, and it'll actually draw the entire tree for you. So it labeled them as noun phrases. Okay, so I believe this is the final example. How to do named entity recognition. Named entities are basically things like organizations, locations, people, places, things of significance usually. This is very important for a lot of things. I mean, if you want to find that a person is typing in a query and they're talking about a place, this would be somewhere where you can take what they entered and say, hey, this is, we just, tag this as being a place. From here, you would import any underscore chunk, that's a module for chunking, POS tag. You would also import the punct sentence tokenizer and the tree bank word tokenizers, and we're going to look at that. There are two different types of tokenizers we can use for this. So essentially, we instantiate both tokenizers, store them in variables, and so we have text. Actually, the text I use is on the next slide. It's really big, and we're going to tokenize these